Some thoughts on React compiler. A lot of us have a lot of thoughts on the compiler, but coming from Dan, I think these will be very useful. I briefly skimmed this thread when it dropped, but I haven't had a chance to really sit and digest it. And there's some interesting bits in here I think are worth digesting, because the React compiler is both really simple and an incredibly complex piece of technology that I think is worth diving into and digging in a bit more on what it is, how it works, and why we care. Let's dive in. Thank you, Dan, as always, for making great content for me. It's undoubtedly an impressive piece of engineering that can make people skeptical. Like, how do you trust something this complex? I think it's being received so warmly because its output is easy to understand. Like, almost all YouTube overviews correctly explain the generated code. I did not expect to be subtweeted in the first piece here. Fair, yeah, LOL. If you haven't already seen the code, I would recommend my videos, but honestly, Jack Harrington's done an even better job. And he has a great video about the compiler where he really dives in and shows what the output code looks like and why we should care. Check out his React compiler in-depth beyond React comp video if you want to go real deep on the inner code. But that's not what we're going to do here because there's enough videos about that. Mine has a bit too. It's interesting stuff. I'm talking about how we think about it. I think it's about more than debuggability. It's more like you know what the compiler is doing because in principle, you could do the same transformation by yourself. It's just annoying to think about code this way. Simple input, simple output. To double down on this point, we've already seen the performance wins you can get when you memoize everything properly. We've seen the benchmarks in things like that one JS benchmark everybody loves to cite where all the roads are moving around a bunch. The one solid wins accidentally. The interesting piece here is that when you run that same code through the compiler, it doesn't end up being meaningfully faster than the memoized version because it's the perfect, simple, memoized solution. The issue with building that way is as the code changes and scales, gets bigger, more things are added, things are removed, all of that, that model gets worse. It turns out when you're thinking a lot about references and memory and how things are allocated and updated, that building it the first time correctly in a simple example isn't too bad. But as soon as the complexity starts to ramp up, as the requirements of the application grow and things start to change, it gets way worse, which is why I think Rust is a bad decision for a lot of projects. Because if the project's requirements are ironed out perfectly and your goal is to just eke out all the performance, absolutely, Rust will be a huge win. But as things change over time, as things are maintained over time, as requirements shift, as expectations shift, as the actual things we're building on top of change, having code that is flexible and adjustable is a value. In the same way that memoizing all your components and all your hooks and data sucks, managing your memory sucks too. Just let the garbage collector do its thing. Just let the compiler compile your memoization for you. I like the solutions that acknowledge that there is a best way, rather than force developers to write everything the best way. What if you just make it close enough? And you do that aggressively. That's where we start to see these massive wins. And that's what the compiler is doing. I think React compiler makes React feel a lot more like Go, as silly as it is to say, because you don't have to manage these things yourself. Can Go code ever be faster than perfect Rust code? No. We don't expect it to be. We expect it to be faster to write, make changes to, etc., and to be close enough performance-wise that we don't care. But if you know how that code works, if you know what Rust is doing, then you go to write Go, you may be like, wow, I wish I could see underneath. This is the cool part of the React compiler. You can go look at the output, and if you know how that deeper level works, you can actually understand what it's doing. But more often than not, you probably don't even need to. Another thing that I found interesting was how it treats your existing memoization. It will rewrite your component with your use memo, but only if the compiler's memoization is guaranteed to cover the same values that you manually memoized. Otherwise, it just skips that component. So if you are doing that manual memoization, you do think you know better than the compiler, it just throws up its hands and says, hey, cool, you do your thing. We got you, which I love. The fact that it doesn't override decisions you did make, it just adds better behavior around decisions you didn't make. That's the magic. If the compiler was making massive changes to the way that your code ran or the behaviors you would expect from it, that would be bad. If you write an explicit decision in your code and then it changes that, that would be bad too. If Go lets you manage memory and then overrode the memory management decisions you made later on, that would suck. But if Go just doesn't have you do that at all and it just does a good enough job for you under the hood, no one would care. And we've seen that as even developers like Prime, who are massive fans of Rust and how it works, are moving to a language that is worse to write like Go, because thinking about these problems is just so painful and miserable. But this is a genius little piece, as Dan says here. This, in my opinion, is pretty ingenious. It means that you don't mostly need to worry about regression in your logic, like effect dependencies depending on memoization, due to the compiler memoizing things differently from how you did. The compiler will just stand aside if it can't match your existing code. Then there's the whole rules of React thing. Those rules aren't new, but they've always been implicit. The compiler enforces quite a few of those rules statically, which means it's the first time we have something like a linter for React language rules, like don't mutate props. Yes, finally. It's actually kind of funny that one of the most underrated wins from the React compiler has nothing to do with the compiler at all. It's the better ESLint rules that you can now apply to your project. Because with React compiler, if you're not following the rules of React, it's not as easy to optimize. It just won't be able to make as performative code. So they need a way for you to more easily see if you aren't following those rules. The existing rules of hooks only covered hooks and only kind of covered them. The new rules of React ESLint plugin covers components, covers memoization expectations, it covers so much more, which means that your code is going to be better even if you don't use the compiler, if you just follow the lint rules instead. There's the whole rules of React thing. Those rules aren't new, but they've always been implicit. The compiler enforces quite a few of those rules statically, which means it's the first time we have something like a linter for React language rules. Yeah, like don't mutate props. I think people forget that props are mutatable. They aren't in strict mode, kind of. It's a mess. But the fact that this is a thing you could do, hopefully most of us realize, like, don't do that. Like if I say function parent and I have const data set data equals, sure. I'll even give a first here. And we return some child, which I'll make here, function child. And this takes in props, name string, cool. Child name data 0. I can even make this a string array. I'll make it names. Props.name 0. Cool. So now we're passing this array of names that we have in this useState call here, which I should import. And this is cool and fun. We have the parent has this data, child names. What if I did this? On click equals names.push new name. Oh, I need to do props.names. Cool. What does this code do? We are now pushing the new name on to this object that we passed in, this array that we passed in. The fact that you can do this and React is supposed to somehow magically handle it is absurd. And this might seem like, oh, why would anyone write that code? I'll show you why they would write that code. Let's say that we put second, then first. But I want to render these as a list. Let's write that list rendering code quick. We have a div, we have props.names.map. We've all seen code like this. We have this data, second, first. We pass it to the child renders this as a list. What if we want this list to be backwards? That seems nice and inconspicuous, right? Right? What's really funny here is that data array here is being modified because we're able to mutate the prop, which in and of itself, disaster. But we also are calling reverse, which intuitively doesn't seem like it is modifying the original array. It is actually changing the array that you started with. The only way to do this code safe would be something like this, where we spread props.names and then we reverse it. So we have a fresh array instance here. But this is where React's prop passing breaks down. It's not even a problem with props itself. It's a kind of a problem with JavaScript where there's no way to say, hey, just because I passed this doesn't mean you can use it however. Do not mutate the thing I passed in. In an ideal world, which believe me, I wish I lived in one, as a functional programmer, arguments would always be immutable. There would be no way to pass by reference. Everything would be passed by value and would not be able to be fucked with in these ways. And I cannot tell you how many code bases I found, especially before strict mode, where bugs like this would cause everything to break down because every time this component renders, it's going to flip the list's order, which is just insane. And it's so easy to do this. Like, so easy. Somebody said, what if we made it as const? Good luck. Where would I even put that? If you read only the prop here, then we get an error that it doesn't exist on read-only string array. So if I do that, but no one's writing code like this. Nobody's wrapping their props with read-only. Believe me, I wish they were, but they're not. Strict mode helps with this because it throws a bunch of errors if you try to mutate something that was passed as a prop. It just yells at you for it. But yeah, I don't think passing as reference makes any sense in React, and I wish it was always pass by value. But since we have to pass by reference because it is JavaScript, we need something to make sure we don't mutate props. And with the new lint rules, you'll just always get those errors instead. It's better than a linter because when you fix the rules violations, your code just gets faster because the compiler doesn't skip it anymore. So we finally have a carrot for writing idiomatic React code, which is good for all other features and generally helps avoid bugs. Great. This is another fun, underrated fact. By saying our code can only be React compiled if we follow the rules, means that random people at your company that don't feel like following the React rules because, oh, I don't really like React that much and I can do this other way instead, those people now have a factual reason they're wrong that isn't just vibes, that is very easy to point at and very hard for them to talk shit on. The compiler being a target that you can dangle a carrot in front of these types of people makes it much easier to pitch these types of things. Very exciting stuff. I love this slide from the introduction talk. Such a clear proposition. Same code, but faster. Who doesn't like hearing that? Python devs because it triggers them, because I've been promised that and not gotten it so many times. But yeah, I love this. And I will say from my experience with the compiler, all the projects I have it running on, I've had to make no code changes too, which is really, really cool. Let's talk about the same code bit. The premise of React Compiler is that all the information necessary to achieve fine-grained reactivity is already in your React code. You can see it with your eyes. That's why it felt annoying that React isn't taking advantage of it. This is a very, very fair point. It's easy for us to read the code and say, hey, these filtered songs only change when song changes. Why do I have to manually tell React, hey, this only changes when that changes? We can read the code and see just from reading it what it's supposed to be. Obviously, it should be memoized. But why do we have to write that every single time? And even with proper fine-grained reactivity, like exists in other frameworks like Solid, they solve this problem differently. You're still being explicit when you do it, but when you're being explicit as you do it, the syntax is a little bit better because you just call the thing that you're trying to bind instead, because there's no such thing as a traditional data value in the like signals tree that exists in Solid. You call the signal to get the data out of it, but then you lose a lot of the re-rendering behaviors and things that make React so nice to work with. Not saying Solid is bad to work with, it's actually very, very nice too, but the mental model has to shift in order to get those performance benefits. What's going on here is that you don't have to make any mental model change at all. The thing that you're looking at is going to be compiled into what it obviously should be doing, not what it is doing, what it should be, which is a gap, to be clear. But I think it's about as big of a gap as JSX is, where does the average React dev know that JSX is just calling a bunch of functions in a chain? Probably not. They probably are just looking at it like HTML. Will the average React dev in the future know that this is being wrapped with a use memo call? Probably not. But their code is faster anyways. This is why I'm excited, because the average React dev doesn't have to care about all of these things. Even if you and I can sit here and nerd out about it in a video like this, the average React dev isn't going to watch this video. The average React dev isn't going to give a shit. The average React dev is a thing I have a whole video dedicated to. If you haven't watched it already, I love that video. I wish it got more views. Watch this one if you haven't. I think it'll be very clarifying in terms of what React devs do and don't expect on the day-to-day. Not the types of enthusiasts and lunatics like y'all who watch my videos, but the people that you work with at your jobs. There's a huge gap between these things, and I think it's important that we acknowledge it rather than pretend it's not real. As such, this is cool because for those people, it just works. In order to do fine-grained re-rendering, the library needs to be aware of the data flow. There's a few ways to do this. One way is to wrap the values in the setters, like view or mobx, so that you're not dealing with plain values anymore. We really like our raw plain values in React. Again, love this. If we look at Solid.js, again, I know I keep using Solid as an example, with signals in Solid, this might look a lot like a hook. The key is that you don't have to call this in a component. You can call it anywhere, but to use first isn't a string. First is a function that when called binds a signal to where it was called and returns the value. So the magic here is now in this effect, whatever signals were called in this create effect will now trigger when an update happens. So if we call set first or set last, it's going to rerun create effect because we called first here. The issue is that first now isn't a string, first is a function. So we want to pass that around. If we want to transform it and do all these other things, we have to plan accordingly. We have to build from the place the value was created to the place where it's changed to the place where it's consumed. It has to stay a function or be wrapped accordingly because it's not bare values. Bare values are what you render in Solid. They're not what you pass around and use in Solid. Whereas in React, as I showed here, I just pass an array of strings. I can put console.log data here, and it just does what you expect. That won't be the case in Solid. I could do this in Solid, and now it will run once, and not again unless I also wrap it in create effect. And if I do this in Solid, to be very clear, this is the difference between Solid and React here. To console log data in React, you do this. And now whenever data changes, we'll console log. To do it in Solid or something similar, we have to wrap it with create effect. We have to call data as a function and pass this an anonymous function that then binds a signal to run this console log when data changes. This is nice in a lot of ways because it's very explicit. You know exactly how the data is flowing, but it's also, I hate to say it this way, not JavaScript in the traditional sense because we have data and we expect whenever this is reassigned that what's underneath gets run. And that's not the case in Solid. You have to bind what runs. It has a lot of benefits. It's the ultimate in performance because you only update when you tell Solid itself to trigger an update. But as nice as that is, and it is nice, it also comes with DX hits. And React has done their best to find a compromise here, and they found a very interesting compromise. Another way to do this is to do what Solid does, splitting the code into two phases, non-reactive construction and then the reactive template. But then you have stuff like when, which is, a real component in Solid, because you can't just do what we're used to, which is like, if data.length is 0, return no data. This code can't be done in Solid. To do this in Solid, I'm going to whiff this because I haven't used Solid recently, you'd have to do like when condition data length 0 data, and then another when not or like else type components. And yes, Solid actually has whens, fors, elses, all these things, because it's not going to rerun your component ever. Solid runs your component once, and then you force updates separately. Making the average app faster is a really good thing. If the defaults lead you to more success, then certain problems disappear or they're delayed significantly. So in that sense, it does have something in common with signals. Idiomatic code is the most performant. Thank you, Ryan, for being one of the few reasonable people about all this. Yeah, so we have a show element, which has when condition, and whatever children you pass it renders, and if the when condition isn't met, then they don't render. But the fact that you need a show component and like a for component, yeah, there's a for component for if you want to do a list. So instead of state.list.map, you would have to do for each state.list, and then the children implies this behavior. These things aren't terrible. These things are interesting. Different frameworks and solutions do this differently. But I've always been amused when people say that React is the ugliest or whatever, because React's the only option that's actually JavaScript, where you're just using the value and using if statements and fors and all of these things in your code. In the Solid example, we encode the data flow graph into the structure of our programs at runtime. We use constructors like when, or as I showed, show, and memo blocks, all to tell the computer what the data flow graph actually is. The data flow graph is already in our React code. We can see it. Songs flows to filtered songs, which then gets passed to the playlist. We see the flow. Why should we have to write more code to force the flow? What if the flow could just happen? We can see the React data flow graph when we look at the code because we have access to the code, unlike React itself at runtime. So React's approach is more similar to Svelte. 3, analyze the code ahead of time and restructure the output program to have fine-grained reactivity. Now we're talking. Also, don't we love the acknowledgement from the React team that Rich Harris was actually right all along? Because I think we'll all slowly realize this over time. Svelte's essentially the following. If previous count does not equal count, update counter count. React compiler is essentially this. Let JSX. If previous count does not count, JSX is this new value. Else, it's the previous value. It's the same principle, but with inverted direction. In React, we return stuff. Yep. Good question. Did Dan go back to Meta? No. Dan can be part of the React team without being at Meta. Only, I think it's like 2/3 or so of the React teams at Meta right now, but they're spread all over the industry. Dan's at Blue Sky. There's some people who are at all sorts of random places, people at Microsoft contributing to React team now. The React team is a much wider set than just people who work at Facebook on React. These aren't completely equivalent, of course. There are many interesting differences that I'm sure folks will dig into. For example, consider a case where you have the following. Const n is list1.length plus list2.length. Suppose an item moves from list1 to list2, so both of their lengths have now changed. With Svelte's default approach, as far as I know, which could be wrong here, changing the list sets off a reactive chain of changes, and the stuff using n invalidates. However, n actually hasn't changed. If we're going from 2 plus 2 to 3 plus 1, their sum is still 4. React compiler bails out here because it compares the result n. This has benefits and negatives and leans into the React thing of we like values. If a shallow comparison of these values, be it strings, numbers, those types of things that are easy to shallow compare, confirms that this thing hasn't changed, it bails out then. Anyway, that's the details. The other thing I wanted to highlight is how projects like this really need the right set of people at a right point in time. There were multiple attempts at building something like this before, but it just didn't happen. One interesting piece here that I learned, some inside info, is that Joe Savona, EN_JS, the other JS at Meta, he's a wizard. He got real deep on the React team because he was trying to get Relay stuff working properly. And getting Relay working with the new React model was so painful that he was ready to rip it all out and upset about it. Then he had enough sit downs with React team people that eventually convinced him that this way was the right way, but he was still upset enough about performance that he ended up building the compiler. But Joe went from frustrated with React for not making it easy to build something like Relay into React, which is the best way to do GraphQL probably ever, where it actually at a low level triggers what things should render as a single query. It's nuts and it's super performant. But to get the performance characteristics he wanted, React had to let him hook in from outside. They stopped doing that, and things like a USIG external store suck and don't support transitions. It's a mess. And he hated that so much that he started arguing with the React team. Eventually understood so well that he realized the problem wasn't how he was hooking into React. It's that he had to in the first place. And a lot of compiler and a lot of his efforts on compiler came from his frustration building data libraries that integrated deeply within React. I know that the compiler was in the thoughts of React team since before hooks, but Joe taking over and being the one to really push it was the result of his really rough experience doing these things in the past. Some of the earlier React compilation experiments were done by True ADM, who, is Dominic. By the way, now working on Svelte at Vercel, which is funny for so many reasons because, yes, Vercel poached somebody from Meta again, but not even to work on React stuff, to work on Svelte with Rich. But how crazy is it that he was working on the compiler for React for a bit and then ended up going to work on Solid? Anyways, prepack was part of the work he was doing, and prepack didn't work out, but it did lead to two things. It led to hooks, because prepack showed how hard it is to optimize classes. It became clearer what an optimizable API would look like, and also resulted in RSCs, which is kind of nuts that their attempts to build a compiler for React led them to building both hooks and server components. Just a wild quote. Sebastian had a vision for an optimizing compiler for hooks pretty early on, but it was just an idea. Nobody on the React team had real compiler expertise, and usually compiler people tend to not be deep into UI, so it was hard to find someone who would be a good bridge between those two worlds. This is an interesting and valuable point. Like, we've already seen how hard it is to get backend in front of people to get along, much less be the same. Compiler people are like a new extreme of backend people. It's like the next couple steps back. The distance between being a compiler nerd and being a web dev person is just so large. The likelihood that they would be the same person is near zero. So finding these people was really difficult. One of the original legends on this was Xuan Huang. Hopefully I pronounced his name right. He used to be part of the React team. He was working on Forget. He gave the original legendary presentation showing how magical Forget could be, but eventually ended up leaving to do his own thing. He's at ByteDance now, and good for him. I'm sure he is super happy. It seemed like he wanted to be working on like platform and application code more again. Happy for him, but he kickstarted the compiler and is a big part of how we got where we did with it. So huge shout out to him for that. But to go back to what we were saying here, he was the first one to pick up the project. He was excited both about the UI part as well as the compilation part, and his work led to a prototype that showed the promise of the approach. The model still wasn't quite right though, and it needed some rethinking. The current iteration of the compiler was done by Joe, who I mentioned before, as well as Mofei Zhang, who is a wizard, Satya, who also presented, did a really good job, and his knowledge of compilers and everything related to them is nuts. Also Lauren, who I had a lot of good convos with. Actually, both Mofei and Lauren were fantastic to talk to, and their understanding of these things was nuts. Legends. And Cassins, I'm not as familiar with John. I didn't get to talk with him at all at ReactConf, but I've only heard great things. But this is like one of those rare wizard teams. Usually when you have teams like this, they're for building the whole thing, like React. To have a team of people this talented, this dedicated and focused, not building React, but building an optional compiler for it is nuts. And these people all have both UI experience and compiler expertise. We didn't have that years ago, but these people come together, and at the point in their careers, they were able to solve this problem. Yep. I don't think this part will get enough attention, and I hope it does more. This is as much a miracle of team building and alignment as it is of technology. I would possibly make the argument that assembling this team and leading them to build this is as impressive a achievement as the actual implementation details themselves. This is so cool. Love these guys for doing this. It's an incredible project. One more quick quote, because I thought this was interesting. Some people say the React compilers are admission that use memo sucks and that we pivoted in response to the feedback. In reality, we had a sufficiently smart compiler in mind the whole time when we were working on hooks, and the dependencies array pattern never would have shipped otherwise. Yeah, as Dan said before, hooks came out of the research on a compiler. We've always been believers in compilers. React started as just.js for pragmatic reasons, so you can just start using it without rewriting your existing stack. This is also why the compiler doesn't rely on any non.js syntax or even static types. It's ruthless pragmatism. This, I'll say, is kind of crazy to me. We saw with Flow how powerful it could be to have new primitives in your language for things like components and hooks, and those will obviously make optimization easier in Flow than in other things, but they wrote the compiler to not need that because they wanted the compiler to work on all projects, especially just JavaScript ones. The very first hooks implementation included some extra runtime methods for a compiler to implement conditional hooks, like hooks inside of ifs, loops, blocks, etc. Obviously, we didn't ship this, but it's another example of how future features influence our current designs. This is also how they justify the use server versus use server action thing. So as much as I love this mindset, I wish they didn't use it to name shit poorly. We're big Svelte fans. They said Dominic now works on Solid and is previously working on the compiler. But it's simply untrue that we'd never considered a compiler before then. Indeed, before the React compiler, there were several failed compiler efforts, like prepack. Sometimes your first, second, or third attempts just don't work out. But when the idea is good, there's no other option but to try harder. Love this picture. Also, this version, where you're this guy, you're scared of this person who's so close, and you end up going through utter shit for an unknown amount of time in hopes of making your way to the end. Best compliment I've ever gotten on the team was, while failing, at least you try hard, by Sebastian Markovic, the legend. This is where the compiler stuff gets so nerdy that I don't know what this is. So if you're actually really into compiler stuff, follow Dan, reading the stuff he's talked about here. I'm not paid enough for this shit. I just write JavaScript, man. But I do want to call out how cool it is that threads like this are happening. There's been this weird vibe that the React team exists in a box somewhere, and they just occasionally come out and show us what they're building when it's ready, and they don't really talk to us or involve us at all. It's so far from my experience, it's absurd. The transparency, both talking to them in person and online, as well as threads like this, kind of just unfurl everything. I can't imagine another team that has this many people depending on what they do, that's this transparent about not just what they're building, but how they got there, the people that led them there, the things that worked, the things that didn't, the mindset that got them here in the first place. React communicates so much that it arguably is a failure of itself, because if you have enough communication out there, people can take any little piece of it and flip it in a way that is misleading at best. And that sucks. But rather than just be scared of that and go and hide and never say anything, they show everything. All of their notes are public. Even things like the broken super early Rust rewrite of the React compiler, they're just in the branch waiting there for anyone to touch. If you go to the Facebook React repo on GitHub, this PR is massive, 358,000 lines. But there's a bunch of Rust code in here. We have the compiler, which has its own JavaScript packages, including the new ESLint plugin and all that. We also have this crates folder because they were actually working on building this in Rust as well. So for the first time now, there's actually a good pile of Rust code inside of the React repo. That's so cool. Almost every other project, company, whatever the fuck, would have just hid this part because it's so early. Like, could someone correct me if I'm wrong? It is my understanding that there's no way for us to actually use Vapor in Vue yet. That it's kind of just like they're working on it, but it's not like a thing that I can go find and like grab the source code for. Oh no, Vue Vapor's here. I'll shut my mouth. This is public now. Really good stuff. The reason I bring this point up is that I find a lot of developers, be it open source maintainers, even like companies working on things, they tend to talk about the thing before they're ready to share it. It's very rare you see what I see with React, where they share it before even talking about it. They just don't hide these things. And then we can figure this out and have conversations ourselves, ask them questions, they'll partake. It's not like they're trying to hide that they tried this with Rust. It's just that they don't want that to be the focus of the messaging. So they just left it in the repo and went back to talking about the important bits. They're killing it with comms. And honestly, kind of breaks my heart that people don't see this as positive, because it absolutely is. I think the way would be better if more teams operated the way the React team currently does. They're trying so hard to be part of the community, to talk about these things and to help us understand not just what they're doing, but who's doing it and why they're doing it. It's so cool. And again, I have massive respect for everyone involved in these projects. And obviously the compiler is dope. Let me know what you guys think. Does this make you more excited about the compiler? Are you more trusting the React team now? Let me know. And until next time, peace nerds.